So, hello. Hi, everyone. Um, I did finish my slides 2 seconds ago, so this is going to be fun. Yeah, so welcome to Sharing Kotlin Code Across Platform is Caring. Let's start with an introduction to understand what we're talking about. Today, when you want to create an app, people think it's like one thing, right? Like it generally starts, unfortunately, because I'm an Android developer, as an iOS app. And it's fine. It's like one thing, self-contained. But then soon enough, your app grows, and you need to expand to different platforms. For example, Android. And then your app starts being two apps already. And then at some point, you start having user accounts. So you add a backend. And again, app keeps expanding. Then maybe you add front end because you want users to be able to use your service everywhere, essentially. And so this app, again, becomes a service, becomes a platform, and has many, many, many different moving parts. It might even be that if your app is complex enough, you will have to develop tools for it, just to handle the scale, the workflow that you need. So today, saying an app means having to potentially rewrite code a lot. Because every single platform is very different, and it is very hard to share anything among them. So this talk is about sharing, specifically sharing code, although saying sharing code is misleading. A lot of people think if I write a cross-platform app, I'm going to write everything once, and that's it. This is never going to be the case, especially when you're dealing with UI. There's only two ways to get the exact same UI across platforms, and that's making a game or using Flutter from Google, which is a new UI framework, because it's essentially a game for UIs. Other than that, you will always have to deal with the platform differences every single time. What you can share, though, is not code, is business logic. As a rule of thumb, you could say that everything that you can unit test, you should be able to share it across platforms, potentially. And you share more than that. So you don't just share the logic. Some people would say you share bugs as well. And that's true, but then you also share the fixes. And so this is more about having a common understanding on what's the problem, solving problems once, and again, like sharing the effort of building something that is not completely separated parts, but it's one unit, and it should work as a whole. Otherwise, you will solve the same problems over and over, and it's going to be painful. Problem is, as of today, there have been multiple attempts, but none of them was very satisfactory so far. So the most classic example, and it's probably the standard so far, is using C++. So C++ runs everywhere. As usual, it is a low-level, let's say, language, runs natively. You can bind it pretty much to anything. And so Dropbox uses this a lot. I know Spotify also has like a common share module written in C++ that they use to share code across all the platforms. Another approach that Google uses is Java to Objective-C, which converts Java sources to Objective-C sources, and GWT, which converts Java to JavaScript. They use that, if I'm not mistaken, in Inbox, and it's how they share the logic among all the clients and the backend and everything. Another way is using JavaScript, which in theory runs everywhere, and is supposed to be easier to write or to get into it, etc. That's a promise that is not always maintained, and we'll see why and how, but still. In particular, I work at a company called Clue, and we'll see how we went from one solution to another. This is like our journey of how we did it, essentially. So Clue is female health tracking app. So women can track their symptoms, and we're going to try to predict what's going to happen next. And at the very core of this, the thing that makes this application work is something that we, as an inside joke, call pause for effect, the algorithm. So the algorithm is our core prediction algorithm. It is the foundation over which we build everything else, essentially. It was originally created by mathematicians and scientists a couple of years ago, and it was in C++. After that, again, the first version of the app was iOS, and so it was converted to Objective-C++, which at the time I didn't even know it existed, but it was a thing. And then when I joined to write the Android client, it was decided that it would be easier if this was in JavaScript. And then after that, it was converted into TypeScript to get some type safety out of the whole thing. So how does it work? If you run JavaScript or TypeScript on iOS, it's OK. They have something called JavaScript Core. It's their JavaScript engine, and it provides bindings at the system level. So imagine having a way. It's like JNI, essentially. So you don't even have to copy stuff over the bridge often. You can just reference it and control things across this bridge. It's pretty nice. It integrates well with the language. You can declare these like hooks in and out. And so it's fine. On Android, you have two solutions. Either you bundle an entire JavaScript runtime, because we don't have anything out of the box available, or you use a web view, which is what we did. And not just any web view, an invisible web view tied to the application context. So pretty. Yeah, no, it was fun. Obviously, saying that it's evil doesn't even begin to cover it. We had so many issues. Of course, performance was awful. We often got back error messaging saying, undefined is not a function. I agree, but doesn't tell me anything. I don't know. Yeah. So we went for a quest to try and find a different solution. And it all started, so I was writing Kotlin already at the time, not even, well, yeah, maybe already even in production. I'm not sure, but I was always very happy about Kotlin, always trying to convince people, saying, oh, you could do this so much easier, oh, blah, blah, blah. And it became an inside joke at some point. And one of the things that I always pushed for was that we could try to rewrite one more time the algorithm in Kotlin, and then use that for the JVM, as well as transpile it in JavaScript for all the other platforms. And so what happened, so again, we wanted to get rid of the web view. That was the important part, essentially. And in its place, spoiler alert, we put Kotlin. The protagonist of this story, wait, no, before that, I want to say why. Why is Kotlin different from the other solution we saw before? The point is that every time, if you use C++, you will cross a bridge on iOS because you need to wrap things a bit, but it's not a huge bridge. On Android, you would have to use JNI. Again, it's a bridge. It's not necessarily a huge bridge, but it all depends how you use it. If it's something you just need to, shoot some data at it, it will compute, and will come back, and you don't do it often, it's absolutely fine. It might even be more efficient to do that than to run JVM code, for example. But if you literally want to take any function in your code and just magically replace that with some shared logic, and so you might end up calling that in a hot path over and over, that would kill your app. So that's not really feasible for the kind of sharing we wanted to achieve. Kotlin, on the other time, promises completely native results. So what you write in Kotlin gets compiled to the real native platform that you use. So for the JVM, it is bytecode. For JavaScript, it is real JavaScript. There's no abstraction layer. There is a minimal runtime, but it's not like dynamic dispatch or any crazy stuff like that. So in theory, it's as if you're writing it by hand. So it's as if you were manually rewriting everything every time, except you're not doing it, the compiler is doing it for you. Plus, one of the things that the other solutions have is that because they want to support all these platforms, they end up having an API that is like a subset of what's like the intersection of what's common between all these platforms. And so they tend to be very limited. And every time you want to do something platform specific, it becomes very hard. In Kotlin, on the other hand, the approach they use is super nice because like on every platform, if you use Kotlin only in that platform, you have access to almost all the capabilities of the platform. Like on the JVM, you can use static methods. You can use everything the JVM gives you. In JavaScript, you can use dynamic types, which obviously are not a Kotlin thing, but in Kotlin for JavaScript, they are. But when you do share code across this platform-specific stuff, you do have this subset, so it is safe to use, but it's also easier to specialize it. So you get the best of both worlds, pretty much. And yeah, and also with Kotlin, you can use native libraries, which is something that is generally hard to do in C++, for example, or JavaScript, because you always have to cross the bridge to access the native library, while here, it's a binding that happens directly, because it's all native. So the protagonist of this story is an engineer in my company, Florent. So he is a backend engineer, and he was assigned to take responsibility of the algorithm. And he was very skeptical about the fact that Kotlin could work at all. And so he started by doing this research project where he was determined to demonstrate that Kotlin was not a viable solution. Great. So he did his research. He tried a few things. He wrote this document outlining pros and cons. And in the end, he came out as a believer. So yeah, it was very interesting because in the end, his notes said that despite everything, despite the fact that at the time there was no multi-platform support at all yet, but it was clear that Kotlin was going into that direction, and it was clear that we could achieve something that we could not achieve in any other way, essentially. So we did try. Just as a reminder, you've probably seen multi-platform stuff at this conference. I did not expect that. Luckily, I did my slides at the last minute, so I could prepare for it. Multi-platform, how does it work? Before 1.2, you would have this flag, X multi-platform. You pass it to the compiler, and you would be able to use these two keywords, header and impl. That was before. Now they are called differently. They're actually called expect and actual. This is probably what you've seen. The previous support before 1.2, apparently, I've been told, will go away, so you shouldn't use it for versions before 1.2, so don't. But this is the proper way to do it. This is how we're going to do it so far in the future, essentially, right? If you don't know, just very, very, very short, expect allows you to declare classes or functions without source code. It's just like a signature of something that you expect to be there on the platform. And then for every platform, you need to actually implement it for real. And so you use actual for implementing the real binding, blah, blah, blah. So that's how it works. What we did was very similar, except without this, without any support for anything. So the idea was, we created this project. We created this project where legacy.js was the old version of the algorithm. And you produce JavaScript for Android, used by the web view, for the backend, and iOS for JavaScript Core. Fine. So what we did was create a new project. Oh, yeah, and this came with like a ton of tests, luckily, because that really saved us. We created this project called Shared KT. And then the idea was that the shared project, little by little, would start grabbing pieces from the legacy.js project, convert them to Kotlin, and the output would still become JavaScript. So from the point of view of the client, everything was exactly the same. We would still see JavaScript, except the implementation of the JavaScript, little by little, was becoming more Kotlin and more Kotlin. And we were shipping that often to see that nothing would break, the tests were passing. In particular, about the tests, we did convert all the tests to Kotlin, but we also kept the original ones. So we are now running, essentially, all the tests across all the platforms, plus the original tests, just in case, and they all pass. So now, after this, after we finally reached the point where we could get rid of legacy, we could finally use the JVM version for Android. And one of the interesting things is that as soon as we proposed the solution of using Kotlin, the backend people were actually excited because they were stuck into using Node.js for a very long time because the algorithm was in JavaScript. But now, with the JVM support available and potentially Kotlin native in the future, they would be able to create a microservice for running the algorithm in a much, much faster way. Keeping in mind we have millions of users, and every time we need to compute anything, we need to compute it for all those millions of users. It takes a long time. Yes, it's not shown here, but the plan, obviously, is to one day put Kotlin native in place of JavaScript Core. Right now, it's wrapped in a way that, from the consuming point of iOS, they don't see it. It's like wrapped in a sort of bridge. So from their point of view, it's like an iOS, or actually Swift now, library. And it just wraps nicely, the thing. In the future, the idea is to keep the same API and just swap the implementation under the hood. That would be interesting. To give you an idea of what it took going from TypeScript to Kotlin, because they're extremely similar, surprisingly. I'll show you two examples. This was, if I'm not mistaken, literally the first conversion we did. We had this type, this is TypeScript, called day, which is a number. And what we did was changing the type to int, and then type is actually type alias. That's it. That's Kotlin. A bit bigger example. This, I don't know if you can see it. Well, too bad. It's a value class. It just wraps a value and adds some static functions to be able to operate these values, like add them, checking if it's 0, and subtracting them, even when they're nullable, etc. I created the equivalent Kotlin version, which is not idiomatic Kotlin, but is just to show how little you need to change to create the exact same functionality in a way that the compiler accepts it. There's a few things that obviously should not be done, like the using reference equals on a double is deprecated. It will work, but you shouldn't. But like this is the first step. That you can do this, it compiles, and then you can just make it better. But that's like an extra step. Now, I did run out of time while making my slides, so I will talk more without any other slide. We did ship this to production. It was successful. The performance improvement on Android has been dramatic, something like from informal benchmarks, 10 times faster to 1,000 times faster, which is huge. And also the startup time has improved dramatically. Like before, it would take seconds to warm up everything, and now it's just instant. So that's really good. Another thing that you should keep in mind is that so what we did was create a Kotlin library, which is different from making a Kotlin app. For example, Kotlin native so far only allows you to create entire executables. And that's not what we want to do. One engineer that used to work with us, iOS engineer Michał, he wrote this article about how he hacked the Kotlin native compiler to be able to execute Kotlin code from Swift as a library. Of course, it's a huge hack. It just shows that it's possible, and it is coming, I hope. They're definitely trying to make it work that way, because that's going to be a game changer, essentially. So again, the difference is that when you make a library, things work differently than what you might expect. And you need to really care about the API you're exposing. Because if you're just writing an app, you don't care about interoperability from the JavaScript point of view, right? Because that's just being executed, and that's it. Well, if you're making a library, people are going to use that code from the other side, potentially. And so if you provide non-idiomatic code, it's going to be a problem, and it's going to be really painful to use. So we did some work on that. Obviously, so our solution, again, was like using source sets. So essentially, what we would do is like we would create this share module as a JVM module. But then we would not compile it for the JVM. We would actually create in different projects type aliases or the actual implementation. Like we would create a fake implementation of something and then not pass it to the compiler, but pass the real implementation for the actual platform. So essentially what the compiler does now, but manually, and it works, you even get compile time safety, because unless all the types are perfectly matching, it just won't compile. So we had no IDE support, but it honestly wasn't that bad, like all things considered. Of course, we did have some pain points, like math has different signatures between JavaScript and the JVM. And so at some point, we would not understand why it wasn't compiling, and there was like one method that was different, or one was missing. So we had to create our own math class, which was fake, but then we would just type alias it to like JVM on one side and wrap it on JavaScript on the other side. So, and then what else? Yeah, and so one of the things we're doing now to provide these better APIs, especially for JSON, for JavaScript, was to wrap a tiny bit the output of the Kotlin compilation to make it just a bit more native feeling. For example, we do create like overloads, let's say, that accept like the dynamic types that JavaScript can produce. And so you don't have to specify use constructors. You just pass an object and it just works, which is something you cannot do on the JVM, of course. The problems we had mostly were, so there is something interesting in JavaScript. They don't support overloads, right? Because JavaScript doesn't have that concept. So in order to make sure that you won't accidentally change a function by changing the parameter types or number of parameters, they essentially scramble the end of the name of each method. Now again, if you're just running this code, you don't care about what even the method is called, because from Kotlin, you don't see that. You only see it from JavaScript. If you're using it from JavaScript, you don't want to have like get name underscore blah, 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 blah. That doesn't make any sense. You just want get name. And so one way to fix that is to put like JS name annotation over the method. And so what ends up happening is that we had to put that method on every single public function, which, again, it sounds worse than it actually is. It's just annoying. But it is something that we're trying to automate, and we hope that support will come from JetBrains to just be able to say, for all this library, just never do the scrounging of the name, for example. Then, of course, JavaScript is a mess in general, so we had to, let's say, juggle all the dependency hell that JavaScript has and like building stuff. Well, that was crazy, but that's JavaScript. Like, there's nothing you can do about that. And I think you will have the same problem even today with the proper multi-platform support, because that's just JavaScript. Packages were also interesting, because we did use packages for the share code, because on JVM, of course, like you want to use them. In JavaScript, you don't. And so one of the things we do now is to sort of proxy the leaves of the packages to like a top-level thing. So from JavaScript, you just use everything as if it was top-level. You don't see the packages, although they are there, technically. So that's also like another thing that's like, not too nice, but still. Last but not least, Typescript definitions. So there's no way so far to generate automatically definitions from Kotlin to TypeScript. And TypeScript needs to, in order to enforce the type safety, to know exactly what types you're using. We are trying to automate that as well by reading the metadata in JavaScript and trying to generate the definitions. So we'll see if that happens. And if we do make it happen, we will open source it, because I'm sure we're not the only one having this problem. Yeah, other things like, for example, you cannot expose. So if you have a companion object with functions on it, you cannot expose those as a static in JavaScript. And so again, there we had to sort of juggle things around. Sometimes wrapping them more happens. But yeah, all in all, it was actually easier than we expected, and we were so surprised when things were just working. Because in the end, we didn't have to change much, especially like functionality-wise. I think it even improved our code, because Kotlin forces you to answer the question, is this nullable? Or a lot of dependencies got solved, and etc. So all in all, it was a huge success, and we're super happy to have been gone down this road. And now we're going to switch to new multi-platform support as soon as possible. And yeah, if you work with anything related to this, I encourage you to take a look, because it is definitely possible. It was possible before, so it's even more possible now. Of course, it is beta, so expect things to work in a certain way, but actually they might not. Yeah, and yeah, that's it. That's all I have. If you have any questions, I'll be glad to answer them.